So as I am trying to predict the variable X based on the inputs A, B, and C. So my inputs are three inputs. So I have to take the three neurons in the input layer. And I am going to predict only one output variable. So I have to take the only one neuron in the output layer. Now all are fully connected. So all are fully connected. All the neurons are fully connected. That means input neurons are connected to the output. And this also connected to the output. This is also connected to the output. And these weights are written as W11. And this is written as W21. And this is written as W31. Okay. And every input A input is going to the first neuron. B input is going to the second neuron. And C input is going to the third neuron. And my output neuron will give the predicted output. My output neuron will give the predicted output. My output neuron will give the predicted output. Right? So if you have any questions, you can unmute yourself. You can ask. I will explain. Now, this is the same model that what we used earlier. Now I want to use one more parameter that is called bias parameter. These weight parameters are W11, W21, and W31. In addition to that, I want to add one parameter that is called as the bias parameter. That is called as the bias parameter. And so this is bias parameter. So this is my bias parameter B. And what the difference for the weight parameter and bias parameter is? For the weight parameters, inputs will be changes. But whereas for the bias parameter, your input will be always 1. The bias parameters, your input will be always 1. Your input will be always 1. So similarly, how we are initialize our weight parameter W11, W21, W31 randomly, same as we are initialize the bias parameter also randomly. But the change is for the weight parameter, you have the different inputs, but the bias parameter, your input value is always 1. So this is my, I am increasing the complexity. Previously, this B value not exist. Now I am trying to increase the complexity of the model by adding the bias parameter. By adding the bias parameter. Okay. Now, okay. Now, so what we will do, same process we will, now we will discuss about the draw of learning to train this neural network model. Later we will implement it in the Python. Later we will implement it with Python. Okay. So what is the first step? What will be the first step? Step 1 is read your data. Read data. So read data means you have to read A, B, C values and your X value, output value you have to read from the training data because it's the training algorithm. And also randomly initialize. What you are going to initialize? You are going to initialize your weight parameters W11, W21, W31, and also you have to initialize your bias parameter additionally. You have to initialize your bias parameter also. You have to initialize. After that, you have to set your learning rate as a 0.1 something and also give the number of epochs you want to run this algorithm. That also you have to give. So what is the second step? Second step. Now take your sample. Let's take first sample. Let's take the first sample. Now I will do one thing. Not second sample for first sample. So we are in the iteration 1. So let's take we are in the first iteration. Now step number 3 is, so take the first sample. We have the 1, 2, 3, 4, 5, 6 samples. Take the first sample. Sample 1. Next step 4 is, so what we are trying to do after taking this first sample and feed that first sample value that is equal to 0.1 and give the 0.2 and 0.3 to your model. Then what it will do? It will help you to calculate the output. It will help you to calculate the output. So for this output neuron, we are not using any activation function. Whatever the input we are getting, that will be the same as your output. So calculate the output. Output O equal to, how we can calculate output O? Output O equal to anyone? We already discussed it. W11 into A plus W21 into B plus W31 into C. This is what we see in the previous case. In addition to that, we have the one more parameter that is called as the B. That is called as the B. So this is my output O value. This is my output value, actual output value. Sorry, the predicted output value. This is called predicted output by ANN. Predicted output by ANN. So what next after getting the predicted output? So this output we are trying to compare with your desired output, that is this one, desired output, and calculate the error. And based on the error, we are going to update the bias parameters. Now, how we calculate the error? How will be the error, anyone? We know that error equal to 1 by 2 into D minus O whole square. Agree? So that means error equal to, where is O equal to, what is the O value? O value, what is the O value? So what is the O value? Already we calculated. O equal to W into weights into your inputs A, B, C, and plus your bias parameter small b. That is the O value. Okay. So here, what are the our weight parameters, or what are our decision variables, or what are the model parameters? One model parameter is the weight matrix, another model parameter is the bias matrix. So if you want to calculate the change in weight or change in bias parameter, if you want to calculate the change in step length for any variable, we have to calculate the gradient of your error function with respect to the each model parameter, each decision variable. I think you agree. That means if you want to calculate, I will go this side. So if you want to calculate delta W, how we can calculate the delta W? Delta W equal to, we know from the yesterday's session, delta W equal to minus eta into dou E by dou W. So dou E by dou W means minus eta. This dou E by dou W can be written as dou E by dou O and dou O by dou W. Both are same. That's equal to minus eta. Dou E by dou O is nothing but 2 comes forward. 2 will be cancelled. D minus O, and O coefficient is minus 1, so it will becomes a plus. And dou O by dou W. Dou O, dou W. Then you have the input that are called A, B, and C. So this is the delta W calculation formula. And similarly, we need to calculate the delta B. Delta B can be calculated as minus eta dou E by dou B. Dou E by dou B. So that's equal to minus eta dou E by dou B can be written as dou E by dou O and dou O by dou B. So that's equal to minus eta dou E by dou O can be written as D minus O, whereas dou O by dou B, dou O, this is the O, and differentiate O with respect to B, you have the only 1. That means delta B equal to, because here in case of the dou E by dou O, it is a D minus O coefficient is minus 1, so it becomes a plus 1. So delta B equal to eta into D minus O. This is the delta B formula. So you have to calculate the change in weights by using this one, change in bias parameter using this one. Previously, we are calculating only change in weight, but because we have the bias parameter, we have to calculate the change in bias parameter also. Okay, and we are adding the bias parameter, one neuron in the output layer. That you have to remember. One bias parameter for one neuron in the output layer that you have to add. Okay. Hope you understand what I'm saying. Now, after calculating the output value, predict the output value, now calculate the step number 5. Step number 5 is nothing but the calculate the change in weights and also calculate the change in bias parameter. How we calculate the change in weight? Already we have calculated. We have the formula, that is eta into D minus O into your inputs A, B, C, and similarly your delta B equal to eta into D minus O. That's it. So calculate the change in weights and change in bias parameter. So after that, what we have to do? Step number 6. So that's nothing but the update the weight parameters and update the bias parameter. Both weight and bias parameters are the model parameters. Both weight and bias parameters are your decision variables, which will decide your error function value. So you have to update both weight and bias parameter so that you can consider W equal to W plus delta W and B equal to B plus delta B. B equal to B plus delta B. Okay. So after getting the W and B values, so what will be the next step? So based on the what we discussed in the previous session, you can apply same thing. So after weights and bias parameters are updated, now move to the next sample. That means you have to update your sample number. So sample equal to sample plus 1. In a training data, we have the another remaining samples, right? We have to do. You have to pass every sample to your model, update the model parameters. You have to pass sample by sample. You have to pass the first sample, later update to second sample, later update to third sample, like that. You have to take the every sample and update the weights and bias parameters. Now check step number 8. That is, so check whether your sample number, if your sample number is more than the number of samples in your training data or not. If it is true, that means you are covering all the samples available in the training data. Then go to next step. Suppose if you not covered all the samples available in the training data, it is a false, then what we have to do? Again, go to step number 4. And calculate the predicted output and calculate the change in weights, change in bias parameter, and update the weights and the bias parameter. So you have to do it repeatedly. Step number 4. And let's assume you are reaching all the samples that is available. You covered all the samples available in your training data. Assume you covered all the samples available in the training data. Then you go to the step number 9. In step number 9, you have to update your iteration value, iter equal to iter plus 1. And in the step number 10, what you have to do is check whether you cover all the iterations that you mentioned in the initialization. At the time of initialization, we will tell number of epochs, or we will tell max the number of iterations. If you reach all the number of iterations, you can stop the training algorithm. Otherwise, you can repeat again, right? So if your iteration value is greater than epoch, that means you covered all the iterations that you mentioned at the time of the initialization. If it is true, then go to next step. If it is a false, that means you are not reaching all the iterations that you mentioned at the time of the initialization. If you said iterations equal to max number of iterations equal to 100, you have to train the algorithm for the 100 iterations. If you are in the 90 iteration, means it's a false. Then go to step number 3. Again, start with step number 3. Again, start with the first sample, like that. So simple. What I'm trying to say is, let's assume this is your samples. These are your samples. Now pass the first sample, update the weights or bias parameters. Pass the second sample, update the weights and the bias parameter. And pass the third sample, update the weights and the bias parameter. Pass the third sample, update the weights and the bias parameter. Pass the fourth sample, update the weights and the bias parameter. Pass the sixth sample, update the weights and the bias parameter. Pass the last sample, update the weights and the bias parameter. If all are covered, that means one iteration is completed. All samples in the training data covered, all are updated, then one iteration is completed. Now, if your current iteration is not maximum iterations, then again go back to the first sample. Again update the weights and bias. This process will be repeated for every iteration based on number of iterations you initialize at the time of the initialization. Suppose if you are taking the epochs equal to 10, you have to repeat this process for the 10 times. Okay. So that's what I am saying. So if the first iteration is completed, you want to run this one for the 10 epochs, then go to the first sample again. That's why I'm writing go to step number 3. Again, go back to your sample. Okay. Now tell me, I want to ask one question from here. The question is, suppose you want to run your training algorithm for the 100 epochs. Your training data has 100 samples. Now tell me how many number of times your weights will be updated. Your algorithm, you want to run this algorithm for the 100 epochs and you have the 100 samples, and tell me how many times your weights will be updated during the complete training process. Anyone, you can use the chart box also. I have the 100 samples and I want to run the training algorithm for the 100 epochs, then how many times my weight parameters will be updated? There is a question I am asking. Anyone, please?
$100.
Hello, sir. How much?
100.
Sir, I want to share my screen once again. You can clearly observe here. You can see this part also. You can see this part also. I want to run this algorithm for the 100 epochs. And in my training data, I have the 100 samples. Now, how many times my weights will be updated? For example, if you are in the iteration one iteration, then for the first sample, weight updated. Again, pass the second sample, weight updated. Pass the third sample, weight updated. Pass the fourth sample, weight updated. Pass the last sample, weight updated. Then one iteration is completed. Again, in the second iteration, again go back to first sample, second sample, third sample, fourth, fifth, sixth, seventh, all times weight updated. Again, go to third iteration. This will be repeated. Now, if your algorithm will run the 1000 epochs and you have the 100 epochs, and if you have the 100 samples, how many times my weights will be updated? That's the question I'm asking.
So for each weight will be updated 100 times. So the total you are asking, or 100 into 100 you are
Right,
asking.
sir. Right, sir. So
Okay,
total
so
number of times the weights and bias
actually
parameters
we
will be
will have
updated.
100 weights, right, sir, for this case?
One weight I'm saying, right? One weight.
Yeah.
So actually we have the W11, we have the W21, we have the W31. So one weight will be updated each weight. That means W11 will be updated for the 10,000 times. W21 will be weighted for the 10,000 times. W31 also weighted for the 10,000 times.
Okay.
Hope you understand, right?
Yes.
Correct. So because this type of questions we will ask in the quiz examination in the canvas. Okay, fine. So this is the complete algorithm to update the weights and the bias parameters of an ANN model using the Widroff learning. So I'm trying to draw the flow chart also. So that will be easy to understand the coding part. So let's start your algorithm. And what is the first step here? You have to read data, that is your A, B, C, and your desired output X. And you have to randomly initialize your model parameters. Model parameters are ANN model parameters. Anyone tell me what are the model parameters we are going to initialize? What are the model parameters for the current discussion? In the current discussion, what are the model parameters? What model parameters we are going to initialize? What are the model parameters we are trying to initialize?
That is ABC vectors, right?
A, B, C are the our inputs, sir. So A, B, C are the inputs. Here you can see. So A, B, C are the inputs. And I'm asking about the model parameters. What are the model parameters we are trying to randomly initialize in the current architecture of
That is
NN?
weights and bias,
Right,
right?
sir. Right, sir. Right, sir. So we have to initialize our weights and bias parameters W11, W21, and W31. And also you have to initialize your bias parameter. In addition to that, we have to initialize your learning rate. And also we have to initialize number of epochs you want to run this algorithm. So these are the main things you have to do it at the time of the initialization. So anyone, so what may be the next step? After initialization completed, we have to set iteration equal to 1. Later, we have to set our sample equal to 1. We are in the first sample. So what will be the next step? What will be the next step? Anyone, please. So we are first iteration. We take the first sample from my data. So what I have to do with that sample?
I think we have to find the O, which is
Right, sir.
weights
Right,
into
sir.
ABC.
Right. So we have to calculate the O. That's called W11 into A plus W21 into B plus W31 into C plus bias parameter. So that's called as the W into input matrix A, B, C plus bias value. So we have to calculate the output. Perfect. So after calculating the output values of a neural network model, so next we have to calculate. We have to do what we have to do. You can see this algorithm also. After calculating
You have
the
to
my
do
O
the
value,
error.
yes. During the training process, no need to calculate the error for every iteration because our motto is to update the weights and bias parameters. So to update the weights and the bias parameters, we have to calculate the delta W and delta B. Definitely, this delta W and delta B are calculated based on the error only. Inside, you can incorporate directly. So you can directly calculate delta W, that's equal to eta into your error D minus O into your A, B, C. That we derived already. That's why I'm giving the expression directly. This derivation is here. This is the derivation. We already derived, and I'm using those expressions directly in the flowchart. Similarly, we need to calculate the delta B also. So delta B equal to eta into D minus O. So after calculating the error, calculating the step length or change in weight and bias parameter, we are trying to update W plus delta W, bias parameter B equal to B plus delta B. So next, tell me what is the next step? As per our flowchart, as per the algorithm, what will be we are updating based on the first sample, we are updating my weights and the bias parameters. So what will be the next step? Sir, anyone please? So as per the sample, first sample, I'm updating the weights and the bias parameters. So what may be the next step?
You take another sample and
Right, sir. Perfect, sir. So we have to take sample equal to sample plus 1. Now we have to check whether all the samples in a training data covered or not. Whether your current sample number is greater than all the samples available in the training data covered or not. If it is not covered, no. If it is covered, then go to the next step, right? So what is the next step? If it is covered, all the samples are completed. So let's assume.
covered means we have to see the iteration number.
Right, sir. Once all the samples are completed, then we are going to update your iteration. Iter equal to iter plus 1. And if it's not covered, that means all the samples are not covered, then we have to go to if all the samples are not covered. In a training data, I have 7 samples here. The first sample is completed. All samples are not covered. We are in the second sample. That means we are not covered all the samples. Second sample is not covered. So then where to go?
So step 2 we have to repeat.
Which one, sir?
We have to repeat from taking the next sample, then again repeat the calculation, right?
O calculation, right? So that's it. So we have to calculate again O calculation. Again, if yes, update your iteration. Again, check for your iteration count. So if your current iteration value is greater than number of epochs. So if it is no, or if it is yes, that means your current iteration not reaches the maximum number of epochs that we initialized. If it is yes, then simply if training process completed, then store weights and bias parameter, calculate errors. If errors are not so much and you and your clients are happy with that error value, then directly deploy your ANN model in the application. And you can stop your process. If your current iteration value not reaches the maximum number of epochs, then where to go? Where to go? Anyone, please? Where to go? If your current iteration is not reaches the maximum number of epochs, then where to go? So again, I'm coming back here. We are in the first iteration. First sample completed, second sample completed, third completed, fourth completed, 5 completed, 6 completed, 7 completed. Then we are updating the iteration count. Now your iteration count is 2. Then again, we are going back to the first sample, second sample, third sample, fourth sample, fifth sample, sixth and seventh. Again, we are going to third iteration like that. So tell me, if my iteration count is not reaches the maximum number of epochs, where to go my step? Anyone, sir, please? You can use chart box also. So then again, we are going back to our sample, first sample, again start from the first sample. So this is my complete, complete algorithm, withdrawal learning algorithm for the ANN model parameter, that means weights and bias parameters update. Hope you are clear with this withdrawal of learning flow chart, the process, complete process, you are clear. Now we will try to implement it in the Python. If it's clear, I think it's clear. We are trying to implement in the Python. So I'm requesting if it is possible, try to respond so that it will create some interest for me also while delivering this session. Fine. Now I'm trying to consider ANN artificial neural network model without hidden layers. I'm not telling about the hidden layers till now. I'm considering only input layer and output layer. So no hidden layer. And I'm considering the linear activation function in the output layer. W11 into A plus W21 into B plus W31 into C plus B. It is a linear. So linear activation function I am considering. And now I'm including the bias parameter also. Okay. Now this is my data. This is the A, this is the B, and this is the C. So based on these A, B, and C values, I am trying to predict the X. I'm trying to predict the X. Now I'm trying to explain this complete code. Okay. Now ANN without hidden layer with linear activation function but with bias parameter. So this is my data. This is my data. Now actually this data is already available in my Google Drive. That's why
I
already
think
sir, please. Sir, please. Sir.
Screen is not shared, sir, I think.
Oh, sorry.
Okay.
Thank you, sir. So I think you are clear with this flow chart, right, sir?
Yeah, it is clear, sir.
It's clear. Okay. Now we are trying to discuss with the implementation using the Python. So actually, this is the data is already available in my Google Drive. Is already available in my Google Drive. So that's with the name of sample data -01. So here in the NND is the sample data. This one is my data. Already this data is available in my Excel sheet. This data is already available in my Excel sheet. Okay. So I want to use this data to train my neural network model. Okay. So then what we have to do again, data. So PD is called as a pandas library. If you want to read the data from the Excel, use the dot read underscore Excel method, and you have to pass the path of your Excel file. So what is the path of my Excel file? Sample data and -01. Just click on these three dots, copy path, and save here. Save here. So now if you run this cell, so it will give the complete data information. Complete data information will be available. So if you want to see the complete data, then you can use data, right click. So this is my 6 samples data is available. 6 samples data is available. Now tell me what will be the next step. Now I read the data from my external source. Just I read the complete data in order to train and test my ANN model using the withdrawal of learning. So what will be my next step? So in the previous session we discussed already. So what may be our next step after loading the data? Whether it's the right or wrong, if you speak out, it's very better. So after loading the data, so what we have to do? Already we discussed in the previous session. In the previous session we discussed it. After loading the data, what we have to do? Anyone, please?
Okay, I think we have to segregate within training data and testing data.
Perfect, sir. So that's called the data split. So we have to split the data for the training and testing purpose. So as I said earlier, see everything we are taking from the natural intelligence only. So in a classroom, what we will follow, whatever the information we have, we will explain. We will use some information to train the students, and we will keep some more questions aside to give it in the examination to test the student. Here also, whatever the data is available, we have to split the data for the training purpose and for the testing purpose. That's it. Thank you, sir. So that's what I'm saying here. So this is called your splitting data. It's very easy. If you understand the previous one, the same code. So to split the data in Python, we have a method called train underscore test underscore split that is available under the sklearn.model underscore selection. So you can take that method. For that method, you pass your original data, this one, your original data, and you have to give your test size. Test size means how much percent of data you want to use for the testing purpose. I'm using the 5% means 0.05. And what happened, this train test method, what it will do, it will split this data for the training purpose and also for the testing purpose. That means out of 6 samples, so maybe 1 sample is going for the testing and remaining samples are going for the training. Okay, so this is the 2 lines are used to split the data, whereas remaining are I'm using for the special purpose. Only I want to know how many number of samples in the training data. I want to know how many number of samples in the testing data. Later, I want to convert this data train and data test into the array format. That's what I am using these lines. That's it. Right. So after splitting the data, we know that we have to randomly initialize our model parameters. So as per our flowchart only, everything I'm going as per our flowchart only. So after initialization, a data reading, and we have to randomly initialize our model parameters, weights and the bias parameters. So this is the random initialization. You can see here, random initialization can be done by using the NumPy array. So weights and bias parameter, np.random.uniform. To generate the random data from the uniform distribution, we have to use np.random.uniform. And you have to give the range. You have to pick the random value from what range. Just I'm considering the -10 to +10. You can choose -100 to +100. You can choose -99 to +900. That's your choice. So, but here I'm using size 1, 1. But here I'm using size 1, 1. Sorry, here I'm using the size 3, 1. But here I'm using the size 1, 1. Anyone tell me why this change is there? Here 3, 1. Here 1, 1. Anyone, please? So in the code, here size is 3, 1. And here the size is 1, 1. So any idea, anyone? And again, I'm asking the participant, if you have any doubt, you can ask. I will explain once again. So what's the reason why I'm taking the 3, 1 and 1, 1 here? Any idea? Because if you observe our architecture, in our architecture, so you have the 3 weight parameters, W11, W21, W31, only 1 bias parameter. That's why I'm considering the 3, 1, 3 rows, 1 column. That means 3 values. 1, 1 row, 1 column, 1 value. So this is the how we are randomly initializing the weights and the bias parameters. Done. So now coming to the our learning process, learning algorithm. So because when we are using the neural networks using any Python library or MATLAB toolbox, we don't see all this stuff. Just we are feeding the data and we're getting the output, but we don't know what happened behind. But the similar programming will be done in the backend. And we are trying to explain from the scratch for the training process of a neural network model. Now, as usual, we have to initialize your learning rate. I'm taking the learning rate as a 0.01. You can see in our flowchart how many loops are there. In our flowchart, we have the 2 loops, right? in our flow chart, we have the two loops. So outer loop is, so now, wait, I forgot. Yeah, outer loop is for the iterations and inner loop is for the samples. That's why I'm using the two for loops. Outer loop is for the, so here you can choose epochs. Epochs equal to 10,000 epochs, and you can use epochs here. So 10,000 epochs. So outer loop is for the iterations, epochs. And whereas inner loop is for the Q1. Q1 is nothing but the number of samples in a training data. Number of samples in a training data. So that's the two for loops. So within the two for loops, what the first step we are doing? Calculate the output. We are trying to predict it out. We are trying to calculate the output. How we calculate the output? It is a matrix multiplication of weight matrix and the inputs, and we have to add the bias parameter. So your actual output O equal to NP dot dot, that means matrix multiplication between the under training data for the corresponding sample, j equal to 1 first sample, j equal to second sample. For the corresponding sample, you have to take the 0th column, 1 column, and 2 column. That means first 3 columns. So first 3 columns are nothing but your inputs. So that inputs, and you have to multiply with x, w. So w into x, inputs into w. Plus you have to add the bias parameter also. So once you calculate the output, so next step is we have to calculate the change in weight. How we calculate the change in weight? Delta W equal to, oh, sorry. Thank you very much, sir. Thank you very much, sir. So I think we stuck with this problem. So here learning rate, yeah. Here learning rate equal to 0.01 and number of epochs I want to run the algorithm. I took the 10,000, or you can take 100 also. If the performance is not good, we can change. And the outer for loop is for the number of iterations, number of epochs, and inner loop for the number of samples for every training data. And what the next step? So inside the two for loops, first calculate the output Y equal to weight into input plus bias. That means output Y equal to NP dot matrix multiplication of your input in the training data. In the training data, for the corresponding sample, that will be 1, 2, 3, whatever it may be, 0th index, index 1, index 2. That means 3 columns. So 3 columns, what are the 3 columns? A, B, C. That are the inputs. So those inputs are multiplied with your weights and add the bias parameter. It will give the output. That's what you are seeing here. Output equal to inputs into weight plus bias parameter. Right? So after getting the output O, then calculate the delta W and calculate the delta B. How we calculate the delta W? That is the eta into actual output or desired output minus your predicted output into your inputs. That's what I'm doing here. Delta W equal to, or dW equal to eta, nothing but learning rate, multiplied by desired output, nothing but the third column. In the training data, third column, that is the desired output, minus O, nothing but the prediction, D minus O, into your A, B, C inputs. Inputs are available here. And the data train, 3 columns are available. So that is the 3 columns. But these three columns are in a row matrix. But I want the ABC as a column matrix. That's why I am trying to use the transpose dot tree, that is called as the transpose. Once you got the delta W, now you can calculate the delta B. Delta B equal to eta minus eta into D minus O. So delta B equal to eta, learning rate, into D, that is the desired output that is available in the third column, minus your prediction O. Once you got the delta W, delta B, or dW, dB, now update the weights and update the bias parameter. Where W equal to W plus delta W, B equal to B plus delta B. That the weight equal to weights plus delta W, B is bias equal to bias plus delta B. That's it. So this is how we write the coding for the withdraw of learning to update the ANN model. Okay. Now you can simply run this cell. So just I am printing the bias parameter, and these are the weights. So after training was completed, as I said in the previous session also, once the training was completed, you have to observe the performance of your ANN model. how we observe the performance of the ANN model based on the training error and based on the testing error. If you want to get the error, you have to know the desired output or actual output, and also you have to know the predicted output on the both training data and the testing data. That means you have to predict the output on the training data, you have to predict the output on the testing data, and these predicted values given to your actual output values and compare and calculate the error. Okay, so that means if you want to calculate the error, first of all, you have to do the prediction on the testing data. So this is the code we are using to prediction on the testing data, right? How we do the prediction? So prediction equal to how we calculate prediction, nothing but O value. O value, how we calculated? That is the, but this time I want to do the testing data prediction. Testing data prediction means you have to use the data underscore test. In the data underscore test, first three columns, that is nothing but the input into weights. That means ABC values into weights plus bias parameter will give the prediction. That prediction value we have to store under the variable or under the array print underscore test. So this will give the your predicted values. I'm getting the predicted value 5.47 something. Now I want to get the testing error. How we got the testing error? I said from sklearn.matrix error matrix sklearn.matrix import mean square error MSE. I want to calculate the mean square error MSE. Okay. So if you want to calculate the testing error, then we have to use mean square error function, and you have to pass your actual output and also pass your predicted output. That it will give the mean square error. So I'm getting the mean square error 0.39, almost equal to 0. If you are not happy, you can tune the parameters again. And similarly, do the predictions on the training data as well. So predictions on the training data means you have to use pred underscore train array and update this one for every sample. So J in Q1 nothing but the number of samples in the training data. And every sample you have to pass, you have to take the input data from the every sample. Why I'm saying that the input data? Because I'm taking the first three rows only. First three rows is A, B, C input data. That input data multiplied with the weights and add the bias parameter, that will give the predictions output. And that output is stored here. If you have any confusion, simply keep it O. And you can pass that O to this matrix. So this is your prediction. You are getting the predictions here. Now you can calculate the error. You can calculate the error same. So from sklearn.matrix, that is called error matrix, import mean underscore squared underscore error, mean underscore squared underscore error. Okay. Now I'm trying to print the training MSE, that's equal to mean square error function you have to call. For that function, you have to pass the actual output in the training data and predicted output from the training data. If you run this cell, then it will give the your mean square error. Okay. If you are happy with these errors, then you can directly deploy your model. You can directly deploy your model. Okay. But if you are not happy, then you have to retrain the model. So maybe you can change few parameters like randomly initialize the weights again, and you can choose the learning rate like a 0.1 and run the epochs for the 100, and again calculate the prediction on the training data and calculate the error on the testing error. So what is the testing error I'm getting? 0.14, somewhat better when compared to the previous. And coming to the training predictions and also calculate the training error. So training at 0.04, previously the 3.85, still reduced. I'm very happy with the error. Now, if everything happy, if the errors are good, and if you are happy with those errors, directly you go for the deployment. Okay, you go for the deployment. I think you are clear with the deployment, right? What is here? So I'm creating an array with all zeros. Okay. Now I am asking the user enter the A value, enter the B value, enter the C value. All the three values I am storing in input vector again. And that input vector I am multiplying with the weights and add the bias parameter to give the prediction. That prediction, that's how we are using that deployment. So deployment is nothing but the using the updated weights and the bias parameters. That's it. Using the updated weights and the bias parameters is called as the deployment. Okay. Now you can run this cell. You can take any sample. So we will take first sample, okay, 0.1. 0.2 and 0.3. So I want to use 0.1 is the A value, and 0.2 is the B value, and 0.3 is the C value, and I'm getting the 4.3. My value also in my data, the value also 4.3. Or you can try another 0.3, 0.4, 0.5. I'm expecting 6.7. You can run this application once again. 0.4, 0.5, and 0.6. And no, not 0.6. No. 0.3, 0.4, 0.5. I want to use these three values. Okay, to check, cross check. So 0.3, 0.4, 0.5. I'm expecting the output 6.7. So I will rerun again. 0.3, 0.4, 0.5. I'm expecting output 6.7. Yeah, I'm getting the 6.9, somewhat close to your output values. So like that, your model will be already trained. That's why it is predicting for these are the inputs. So we will get this say the output. Okay, now that's how your model will be trained. That's how your model will be deployed. So I think it's clear up to now, training and everything. Okay. If you have any questions, please. No? Fine. Then we will move to some other topic. So this is the last topic for today. So in practice, in practical problems are the real-time problems. Your input variables and the output variables are not linear. It is highly non-linear relation mapping. Don't expect you have a linear relation with your input parameters and the output parameters, input variables and the output variables in the real time. Suppose if you want to, we are building an application for a COVID prediction. Don't expect your COVID column, last column is a linear relation of your fever, oxygen, and cold. It's not like that. It is highly non-linear. So if you are building the neural network model with a linear activation function, then it won't work well. It may not work well. Then what we have to do? Then we can include the non-linear activation functions. We have to include the non-linear activation functions. Instead of the linear activation function, we have to include the non-linear activation function. Okay. So again, I'm trying to explain the neural network model with respect to the non-linear activation function. Okay. So let's consider the same example, same as previous one. So I have the three inputs, A, B, and C. I'm trying to predict the output X. Okay. So I have the multiple samples. Okay. Now we have to build the architecture of ANN. So this is my ANN architecture. Now this ANN is designed to predict the output, only one output. The predicted output, I want to keep it as a O. Okay. Based on the three inputs, A, B, C. So this ANN model will take the three inputs, A, B, and C. A, B, and C. Okay. Now, you can give this one input to the one neuron and second input to the second neuron, third input to the third neuron, so that my input layer has the three neurons, whereas output has the only one output. So output layer has the only one neuron. Now all are directly interconnected. So this is called W11, this is called W21, this is called W31, and you have the one bias parameter B, and bias parameter input will be always 1. It is same, right? Same what we considered in the earlier case. But the only change here now is, so now previously I consider the linear activation function so that my output O equal to W11 into A plus W21 into B plus W31 into C. But this time I want to use the nonlinear relation, nonlinear activation function. We have the multiple nonlinear activation function like sigmoid and ReLU and tan hyperbolic. So we have the different activation functions. Sigmoid is nothing but so it will be varying from the 0 to 1. The values will be varying from the 0 to 1, and this will be represented as so f of x equal to 1 by 1 plus e power minus x. That is a sigmoid activation function. Whereas the ReLU activation function will be looks like this. So if the input to your activation function is a positive, then the same value will be comes. If the input for the activation function is negative, then it will be 0. So this is how it looks like. So ReLU activation function is mathematically modeled as maximum of 0 comma z, where z is the input to the ReLU activation function. If the z value is a positive 1, 2, 3, 4 like that, you will get the positive values like this only. Okay. But if the z values are negative, -1, -2, -3, then it's always a 0. It's always a 0. So that is the mathematical modeling for the ReLU activation function. Similarly, you have the tan hyperbolic activation function. So tan hyperbolic activation function is e power x minus e power minus x divided by e power x plus e power minus x, where x is called as the input. X is called as the input. Okay, or you can take it as z. Your choice. You can take it as z also. Z is the input. Here also you can take it as z. Z is an input. So this is called as f of z. So it is the tan hyperbolic activation function. And whereas tan hyperbolic activation function, the activation function will be varying from the +1 to -1, +1 to -1. That is the tan hyperbolic activation function. So we have the different type of activation function. Here I am trying to explain with respect to the sigmoid activation function. I am using the sigmoid activation function in the output layer. I am trying to build the nonlinear relation between the ABC inputs and the outputs. Sigmoid activation function. So sigmoid activation function can be represented as a f of z equal to 1 by 1 plus e power minus z. That means if your input, that means input is nothing but the z. Z is nothing but the W11 into A plus W21 into B plus W31 into C plus your bias parameter. That is the total input to your output neuron. But in the output neuron, previously I had the linear activation function, my O equal to same z. But here I am using the sigmoid activation function. So my output to O equal to 1 by 1 plus e power minus z, where z equal to this part. Where z equal to this part. Okay. So this is my output now. This is my output. So this output is compared with my desired output D that is available in the here. Desired output D that is available here. Now, based on this error, both weights and your bias parameter will be updated. Both weights and bias parameter will be updated. So, how it will be happening if you are using the nonlinear activation function like a sigmoid? So, it will be changes. The delta W expression, delta B expression will be changes from the activation function to the activation function. Now, I am trying to explain with respect to the sigmoid activation function. Okay, I'm trying to explain with respect to the sigmoid activation function. And before that one, I want to tell one thing, that is, if f of z equal to 1 by 1 plus e power minus z, this is called a sigmoid activation function, you can try what happened if it is f dash of z, nothing but the dou f by dou z. So dou f by dou z for the sigmoid activation function is, that is nothing but the f of z into 1 minus f of z. So you can try also, because we don't have time to derive this expression. So you can try to differentiate this function with respect to z, you will get this only. Okay, if f of z is a sigmoid activation function, its derivative equal to f of z into 1 minus f of z. That you have to remember. Fine. Done. So hope you understand as of now. And further, I want to do the few more derivations. Right. Now tell me what is the error. Error equal to 1 by 2 into d minus o whole square, where O equal to, 1 by 1 plus e power minus z, where z equal to, we know that W11, W21, W31 into A, B, C. That's nothing but the W11 into A plus W21 into B plus W31 into C plus bias parameter. We can simply call it as a W into what we can call here ABC input plus bias parameter B. So this is my Z value, right? Now Please respond how I can calculate the change in weights. Anyone, please? How I can calculate the change in weights, please? How I can calculate the change in weights, delta WB. How we can calculate? Yesterday we discussed how we calculate the step length. Today also we discussed how we calculate the delta W, delta B. I am asking again the same expression, how we can calculate. So my error is, this is my error. And I want to calculate the delta W. Please, anyone, please. If you are responding, that will be very interesting for me. I am asking, please. How I can calculate the delta W? Because these things are not available. So I'm trying to explain from the scratch so that you can understand the neural networks backend mathematics easily. Anyone, please? How I can calculate the delta W?
Delta W, we have to take derivative of the function.
Right, sir. Thank you very much, sir. Delta W is minus eta into dou E by dou W, right, sir? So you can further write this expression as minus eta dou E. This is the E, right? Here we are unable to see the W, right? Only we are able to see the O. I want to write this one as a dou E by dou O and dou O by dou W. It's okay. It is nothing but the dou E by dou W. Again, further I want to do the splitting the partial fractions, dou E by dou O, but in O, I don't see W. I see only Z. So dou O by dou Z. That means this is your sigmoid activation function. I am trying to differentiate my sigmoid activation function with respect to Z. Multiplied by, I can write dou Z by dou W. That's the same, right? Dou E by dou O, dou O by dou Z by dou W. Now, what is the delta W? That's equal to minus eta. Anyone, please tell me what is the dou E by dou O? What will the dou E by dou O? Because these derivations are measured. These two come forward. Yes, sir. This will become a plus. Now it is a D minus O. What is the dou O by dou W? You can map the sigmoid activation function. So dou O by dou W I am asking. Dou O by dou Z, sorry. Dou O by dou Z. It will be O is the 1 by 1 plus E minus E power minus Z. I am trying to calculate the derivative of O with respect to Z. What is the derivative of the sigmoid activation function? We all discussed here. F dash of Z equal to F of Z into 1 minus F of Z. So dou O by dou Z is nothing but the O into 1 minus O. And what is the dou Z by dou W? Dou Z by dou W, nothing but the A, B, C. That's it. So this is your delta W expression for the your neural network model. If you consider the sigmoid activation function. So now tell me how we can calculate the delta B. Anyone, please? Delta B equal to minus eta dou E by dou B. That's equal to minus eta dou E by, E I am able to see only O. So dou E by dou O into dou O by dou B. But still I can do further splitting, minus eta dou E by dou O into dou O by, in O I am able to see Z. So dou O by dou Z into dou Z by dou B. Now what is the value? Minus eta dou E by dou O, 2 come forward, D minus O, because the O coefficient is minus 1, it become a plus. Dou O by dou Z is a sigmoid, so O into 1 minus O. Dou Z by dou B. So what is the dou Z by dou B? Dou Z by dou B, that's simply 1. So finally, my expression for the delta B equal to eta into D minus O into 1 minus O. That's it. That's it. Now I want to use my algorithm back. This is called the back propagation algorithm. What I'm saying still now is a back propagation algorithm only. Why is it called as back propagation? Because uh, uh, because in the forward propagation, I'm calculating the O value. I'm calculating the O value, right? W11 into A plus, W21 into B plus, W31 into C plus B, and apply the sigmoid active function. I'm getting the O. This is called as the forward propagation, FP. And in the backward propagation, what I am doing, based on this output, calculating the error. Based on the error, we are calculating the delta W and delta B, and we are updating the weights. It's called the back propagation, forward propagation and backward propagation. In the forward propagation, we are calculating the output values. In the backward propagation, we are updating all the model parameters. It's called the back propagation algorithm. Simple way I'm telling, but it's very complex if the complex of the model increases. Fine. Now you are clear with the delta W calculation and delta B calculation. Now I want to draw the flowchart directly instead of algorithm and flowchart. I'm trying to draw the flowchart directly. So please help me to draw the flowchart. So with that flowchart, we will close the session for today. Tomorrow we will include the complex of the model further. Slowly I'm trying to explain. That's why I'm not using the direct codes and everything. I'm trying to evolve the model. Fine. Now we are trying to use start. Sorry. Start. Now tell me what is the first step we have to do in this case? Please, anyone? I am sure if someone is following, definitely you are able to give this answer for this one. What will be the here? So you have to read your data. The data may be inputs and your outputs, and randomly initialize what you are going to initialize, your weights and your bias parameters, and you have to initialize your learning rate, and also you have to tell how many number of iterations you want to run the algorithm. So next step will be you have to set first iteration, and also you have to set your sample, the first sample. Now tell me what you have to do. Same process, again same, only the formulas will be changes for the delta W and delta B. The formulas will be changes for the delta W and delta B. So anyone please? So you have to calculate your output values. How we calculate output values? We can't calculate output values directly here, right? We can't calculate output values directly here. So how we can calculate? First, we have to calculate the input to your output neuron. Z equal to W11 into A plus, W21 into B plus, W31 into C plus bias parameter. You can call it as a W into A, B, C plus bias parameter. After calculating that, then you can calculate the output. O equal to 1 by 1 plus e power minus z. That's how we can calculate your output of a neural network model. So after calculating the output, what you have to do? You have to calculate the change in weights, delta W, and change in bias parameter, delta B. How we calculate the delta W? We already created the equation. We derived the equation. That is eta into D minus O into 1 minus O into A, B, and C. And how we calculate the delta B? That is the eta into D minus O into 1 minus O. That's it. So after calculating the delta B, so what we have to do? Update the weights and the bias parameters. So W equal to W plus delta W and B equal to B plus delta B. Okay. So after that, so you have to, so what's the next step? What will be the next step? After updating the weights and the bias parameters, our next step is so we have to update our sample number. So sample equal to sample plus 1. Now we have to check whether we cover all the samples in the training data or not. If your sample number is greater than number of samples in the training data or not. If it is no, where to go? We have to go to the calculation of our Z and output. Okay. If it is yes, then go to the next step. Next step is nothing but to update your iteration count. So iter equal to iter plus 1. And again check whether you reach all iterations or not. So iter is greater than number of epochs or not. So if it is the S, reach the number of epochs, if it is the S, then you have to, what you have to do? You have to store model. Store model is nothing but the save model, or store model is nothing but the store your weights and the bias values. Okay. And calculate errors. And if you and your client is happy with the errors, then deploy your model. That's it. That's a complete process. So then you can stop the algorithm. If it is no, that means your number of iterations are not reached, then you have to go back to the first sample and repeat the same process. So this is the complete flow chart for the ANN model training. When you are including the nonlinear relation, nonlinear mapping using the sigmoid activation function, So I think it's a complete flow chart for this one. So I hope you understand up to here. Okay. So we can write the code same process. Only in our code you can change only delta W expression and delta B expression, whereas you have to calculate the output values based on the exponential function. Okay. So this is the complete thing for the simple ANN model. Initially, I take the simple ANN model with linear activation function. Later, I'm adding the bias parameter. Later, I'm adding the nonlinear activation function. And tomorrow session, we will increase the number of layers. Till now, we discussed the input layer and output layer. Now, I want to use the hidden layers also. If I use the hidden layer, then how it will be changes. That we will discuss in the tomorrow's class. Okay. So if you have any questions, so please ask now.